Hello everyone, today I'm going to talk about my project Lissajous curve apparatus. First, I'd like to talk about its history. So, this family of curves was investigated by Nathaniel Brodich in 1815 and later in more detail in 1857 by Jules Antoine Lissajous, who gave this family of curves his surname. So, what is a Lissajous curve? Lissajous curves simply visualize sound by combining a point which oscillates vertically with another point which oscillates horizontally, hence creating a group of curves with complex harmonic motion, namely Lissajous curves. Now, I'd like to explain these curves better, so I will tell you a little bit about the theory. To create a Lissajous curve, we need 2 points that make simple harmonic motion on the axis perpendicular to each other. As can be seen, x and y are 2 different simple harmonic motion equations and the phase difference between them is delta. Frequency ratio in these equations, A over B, determine what the shape will look like. Capital A divided by capital B gives the aspect ratio of the resulting shape. The phase difference delta gives the rotation angle of the shape. The reason we call it the rotation angle is because the phase difference makes the shape look like it is rotating. For example, here we see how a shape with frequency ratios of 1 over 2 and a phase difference of pi over 2 is formed. Now I will briefly summarize the experimental setup I built to obtain these curves. First, I started by cutting the bores in the dimensions I determined. Then, I built the main body and added various reinforcements to make it stronger. Next, I attached small mirrors to the end of the tuning forks. After that, I made the tuning fork holders and laser holder that I built to attach it to the main body. I mounted the tuning fork onto the main box in the channels I opened before. Since it is very important for tuning forks to vibrate at the right frequency, the system had to be quite stable. So I mounted 2 pieces of wood next to the tuning fork holders to fix them really well. Finally, I mounted the laser pointer in its predetermined place. Thus, I have completed the construction of the experimental setup. And here are some pictures of the experimental setup from different angles. Now, I will tell you how to get a Lissajous curve with this experimental setup. To better understand how it works, we will look at it from the laser's point of view. Let's also turn off the lights to have a nice view. The mechanism works as follows. As can be seen, 2 tuning forks, on which we attach a mirror, are brought to the angles where the reflection will be provided. When we vibrate these tuning forks, the mirrors attached to them will vibrate at the same frequency. When the tuning fork first touched by the laser is in the horizontal position, we will get a simple harmonic motion in the horizontal direction. Then, when the laser bouncing off the mirror hits the second tuning fork, it will also be making a vertical, simple harmonic motion. Since these occur simultaneously, the image created by the lasers bouncing off the tuning forks on the wall will create a Lissajous curve that makes complex harmonic motion. Now let's watch how these curves are formed. Here is a comparison of all the curves I have obtained. This was my project. Thank you for listening to me.